And we are still seeing people joining our webinar, so we will be still waiting for 1 minute until everybody has the time to join it, and then we will kick it off. Still a couple of people joining, but we will not wait any longer. So hello everybody, and welcome to our webinar, Smart Water Starts with Smart Data. My name is Adriaan. I'm the Chief Customer Officer of Timeseer.AI, a sensor data quality management software solution. But we will talk more on that later on in the session. Let me first welcome our presenters. Rene Kersten from the Dutch water utility company Vitens, and then we have Christian Montag in the call as well from iFLUX. They will be sharing their learnings on implementing Timeseer in the coming minutes as well. But before we dive into the real content, let me first share some housekeeping rules for the webinar. So a couple of things that I want to notify you about. So audio, everybody is muted during the session to just reduce the background noise. If you have any questions or you want to engage with somebody who is presenting, please use the Q&A box that is available. So post your questions at any time. We will make sure we address them during the Q&A segment at the end of the session. And if we don't come to all the questions, we will share them afterwards as well with an answer to you. The materials, so the presentation slides and the recording will be shared after the session. And then in the current world, privacy is important, so be aware that the session will be recorded. So if you stay here, that you also provide your consent to being part of the recording as well. Right, housekeeping done. Then let's dive into the real stuff. We actually have 3 parts for you today in the webinar. The first one, I will be covering a very short introduction on why sensor data quality is, like we believe, one of the missing building blocks in digital water applications. Then, second of all, we have Rene on the agenda. He will talk about the implementation of Timeseer at Vitens, both focused on use cases and a live demonstration of how the software is currently being used at Vitens. And then we have Christian, who will dive into why sensor data quality is a game changer, specifically for groundwater insights and the work iFLUX is doing. All right, first introduction. So I don't have to tell you, water utilities face core challenges today, like scarcity of water, aging infrastructure, rising energy consumption, growing populations, name it. And to face most of those challenges, making better and more use of sensor data will be critical. However, what we have seen is when the sensor data is unreliable, so are also all the services making use of this data, leading to inefficiencies within organizations, regulatory issues, unhappy customers. So it actually only makes things worse if you look at it from that point of view. To illustrate this, the impact of bad sensor data or unreliable sensor data spreads actually across the entire organization. So it impacts, on the left-hand side, people manually working with sensor data, typically data analysts, business analysts, data scientists, for example, that are spending really significant effort on manual data validation to clean data, to get it ready for analytics, to get it ready for reporting. So it consumes a lot of resources. It's not really scalable, and a lot of manual effort is being spent there. Then the middle block, which is the second one, Where it also impacts is, organizations really scaling enterprise sensor use cases. So really enterprise data teams think about digital twins, for example, that needs to be rolled out. You get too many false alerts in leak detection applications, for example, due to data quality issues. So that's another part of the organization where you can feel that impact. And then the last one is really ensuring your sensor reliability. So if you really have to monitor at scale, SLAs, for example, for smart meter providers, monitor at scale all the smart meters that are being rolled out at households, for example. It's resource intensive if you have to do it manually, so you actually need technology to do so. And because of the fact that bad data or unreliable sensor data impact all those dimensions within an organization, we from Timeseer really believe that you need one unified layer actually to address those challenges. And that's actually what we have done from a Timeseer point of view. So we have built a solution that manages all your sensor data in a unified and governed way. So first of all, Timeseer is able to automatically identify sensor data quality issues, but we can also then proactively resolve them before they really hit your data-driven applications that are actually making use of that data. We always talk about we are really doing the heavy lifting of sensor data quality for you, so you can be actually busy with what you need to be busy, the real things that make an impact. So from our point of view, imagine sensor data that's always clean, reliable, ready to power your operation, whether it's for energy optimization, accurate billing, consumption forecasting. That's really what Timeseer is providing to you. That's also what Rene and Christian will be talking about on how they are leveraging Timeseer to do this. We will also be sharing some small glimpses of our software actually, and that's something I want to share with you right now as well, how we actually use our Timeseer application to really quickly set up data quality and sensor data quality monitoring, because that's typically a requirement of our customers. You really want to do it quickly. You don't want to spend huge amounts of time in setting those up. And that's really where the IP of our technology comes in. So I'm just quickly going to show you how you set it up. In Timeseer, you have use cases where we actually have predefined templates depending on which industry you're in. We have some generic applications, but we have specific things for water utilities. I'm going to pause there, that it's not going too quickly. But you will see we have application-specific things related to water quality monitoring, governmental reporting, specific sensor templates, for example, that we're using, where you can then use that application template, for example, select your data. So the data that you want to monitor can be connected sources, like at Vitens, we connect to OSIsoft Pi, for example, to monitor the data. You can easily select the data you want to monitor. And then we're actually going to select a first time period to analyze in Timeseer. That goes very quickly. And then actually Timeseer is going to do the magic in the background. So we are actually going to validate what is actually part of the data, and we're going to come up automatically with a suggestion on what is the ideal configuration to start monitoring. So looking at, is the data valid? Is it available? Looking at data integrity, drift, for example, specifically. I mean, we can also configure some things to already repair data, for example. Of course, if you still want to customize this, you can add different checks that we can run on the data. We have more than 100 out of the box in Timeseer. And then actually Timeseer is going to run the analysis, tune the algorithms for the detection based on the data that you have selected. And based on that, Timeseer is already going to provide you with insights of what we detected on that historical data, which is really a summarized view. So you will see we get a list of the kind of to-do list. What are the things we detected? Stale data, for example, flat lines, data gaps, duplicates in the data, whatever that might be relevant for the case you're looking at. You can still go back to configure this, but you can also publish this, and then you can actually, with one click, make sure that it runs live. And that's also what Rene and Christian will be showing from their end, how it then works in a live setup. So that's really the end-to-end flow in setting up things where we use templates, guide you based on AI techniques to come up with a setup that you can use then in your day-to-day operations to improve your sensor reliability and quality. So it's a really quick overview of, first of all, why is all of this important and how do you set it up in Timeseer? And that really brings us to the second part, which is Rene Kersten from Vitens, who will share a bit more into detail of how Vitens is actually using our application. So Rene, I would say the floor is yours to give an introduction and then dive deeper in use cases.
Okay, thank you, Adriaan. Adriaan is show later up a slide. I would like to explain more about it, but before I do that, I would like to introduce myself and tell you something about Vitens. My name is Rene Kersten. I am working almost 40 years at Vitens. My position is Senior Functional Application Manager of the OSIsoft Aviva Pi system. The Pi system is a system that can store real-time data from sensors based on date and time. And the system can also provide data infrastructure based on the Pi asset framework. Vitens is a drinking water company that supplies drinking water based on groundwater. We use approximately 230 locations for pumping, purifying, and distributing drinking water. The Vitens strategy is to make the transition from craftsmanship to data-driven work. To realize this strategy, we collect a lot of real-time data from our locations and sensors in our distribution network. For now, we collect over 12 billion data points every year. It's a lot. Because we want to work with complete, reliable, and valid data and do not want to have to check the many data points manually, we started a Timeseer pilot a year ago. If you would be so nice, Adriaan, to go to the first slide.
Right. Thanks, Rene, for the introduction. Maybe quickly an overview still before Rene will dive into one of the specific use cases and provide you a live demonstration. Rene mentioned the pilots, and this actually resulted in a couple of cases that were now running live at Vitens as well. One is really monitoring of AMR meters and data SLAs over there. That's what Rene will be focusing on in the next slide and also in the live demonstration. The second one, for example, is data validation for management and then also external or governmental reporting. And then the third one is sensor and data reliability for groundwater management. And that's actually what Christian will be talking about in the second part as well, on how Timeseer provides reliable data in there as well. So it's actually a collaboration, iFLUX, Vitens, and Timeseer that we will be seeing over there. So these are a couple of the examples of the use cases that we are currently handling with Vitens. And then Rene, the floor is yours again to go a bit more into detail on the specific things we're doing with the AMR meters.
Okay, thank you, Adriaan. The most important thing on this slide is that I want to tell you about the slide is that we checked multiple data sets, but that the check on the return flow of the AMR meters at the large business market had an immediate effect on the business operations. That is the upper left. Okay, it's not going well now. I see nothing. Excuse me.
You're still seeing the screen, Rene, or not?
No. Can you take it over for a moment, Adriaan? Then I start again.
Yeah, we can wait for a moment as well.
Okay, I have a problem with my security. One moment.
That's how it goes. No problem. This is an illustration that is really live.
Okay. I'm back.
Okay, no worries.
The most important thing I want to tell about this slide is that we checked multiple data sets, but that the check on the return flow of the AMR meters at the large business market had an immediate effect on the business operations. Based on the check by Timeseer, it appeared that several meters registered return flow of water. Based on that, we visited all locations, and it appeared that the check valves were defective, and we replaced all of them. And I think it were 15 valves we must repair and replace. So that is an important benefit of the first use cases we have implemented within Vitens. Then I will go to the live demo, but before I go to the live demo, can I tell you that over time we have been checked more and more data sets. I would like to show you some of this live, and then I will zoom in on the check of the QMAX of the automatic meter readers of the large business market. We make contractual agreements with the large business market regarding a maximum purchase, the QMAX. If this purchase is exceeded, a fine or adjustment of the contract may follow. To check the QMAX, we configured a flow with a Timeseer that only checks for the jump outlier upwards. My basic routine is to check every morning if an event frame has been generated from the 1000+ AMR objects. I then zoom in on this for further analysis, and depending on the result of the analysis, I suppress the event frame. I shall show you that in the demo. We still have some challenges with the hash system of the AMR objects, which means that incorrect peaks are still being registered. That is also the reason why we are checking on the QMAX. I can now step to the live demo. Thank you. Okay, Adriaan, thank you.
Yeah, you should be able to share it now, Rene.
Okay. I must go to Timeseer. Why is my mouse not working? I must, okay, yes, I'm coming. Is it correct that you see my Timeseer screen?
Yes.
Okay. So what you see here is an overview of the quality dashboard. This dashboard is freely adjustable under a few options. You can see here that we have configured several flows, but we have selected a few of them. And because we have selected a few of them, you see this quality dashboard. I going zoom in for the AMR grootzakelijke markt QMAX analysis, but we also have configured flows for pressure meeting in the distribution network. For now are that 320 series. We do something with water quality on a production location. We have also here not the pi tags only, but also 6 series sets, and that we are using for our management reporting. We are also busy with that. So we are using Timeseer on several parts of our data sets. When I go zoom in, and I do that every morning to the AMR grootzakelijke markt QMAX. You can see here the results. And when we zoom in, you can see that we have issues with 5 objects. I only check the data on the KPI jump outlier upwards. So when I see this, let's go to the first one. Normally, I make a selection. You can also select the red area, but what I do, I select the whole week. I visualize. And the next thing you see that there is a peak of about 400 cubes per hour per 5 minutes. What you can just say here is a very high peak. And when I do then is to go further back in time to see if this is more happened in the time before. So I have a very long period, and what you can see is this customer has a very normal pattern, but we Timeshare detected here a high peak, what I do then is that I go further back in time, and based on this analysis, we really need to investigate further what causes this high peak. Because we know that for now, what I mostly do is to suppress the event frame, so that when I come back tomorrow and I go look to the dashboard, I won't like to see this anymore. That's the following step I will do. Take a little of seconds. And when I go back to the dashboard, I had 5 critical objects, and for now I have 4 critical objects. That is what I would like to show you with this demo. At the moment, we are still exploring Timeshare and its capabilities, but for now I can give 3 important recommendations. We have more recommendations, but I have picked 3 important ones. The first one is just get started. You learn by doing and experiencing. Also see Timeshare as a kind of data insurance. You can make agreements with internal, external customers, transparent and secure them. And the last one is Timeshare is an important part of the data infrastructure. You would like to have one version of the truth. I would say thank you for your attention for so far.
Thank you, Rene. Can you stop sharing your screen, Rene?
Yes.
I can put it on again.
Now, okay.
All right, perfect. Thank you. Then you should see my screen again. All right, perfect. That works. So thanks again, Rene, for showing these concrete examples. If there are any questions already to Rene, please feel free to post them in the Q&A box, and we can take them after the session as well. And that actually brings us to Christian, so who will share his insights in why sensor data quality is particularly important and a game changer for iFLUX. So Christian, go ahead, and you can take over the screen.
Okay, thanks Adriaan, and thanks Rene for sharing. All right, if all is well, you see my slides now. Maybe to start off, data is always a means to an end. We're using data to accomplish something. What I'd like to discuss with you today is how data could benefit our shared water future. Let's see here if I click. A few key facts. You probably know, because you're in the water world, only a very small percentage of Earth's water is actually usable and available freshwater. And 99% of that liquid freshwater on our planet is actually groundwater. Half of the drinking water we produce, at least in Europe, comes from groundwater. So all of this to say, groundwater is a resource worth protecting. Problem is that groundwater is out of sight. And you know how the saying goes, out of sight, out of mind. That's not the right approach if we want to manage this key resource for our future. Our groundwater system is under a number of systemic threats. we have contamination, over-extraction, and climate change. And climate change is causing rising sea levels and saltwater intrusion. It's causing drier dry periods and wetter wet periods. We have contamination that's on the move from all of these factors. So you have quite a volatile system that if we want to ensure it for the future, we need facts and data so that we can manage based on evidence-based insights. Enter iFLUX. We offer the insights and monitoring to be able to do just that. What we offer is an advanced aquifer intelligence service. We offer it as a DaaS model, so as a data as a service model, which means that at the end of the day, we work as a trusted partner for our clients, and the client really just pays at the end for the data that's available to them so that they can, define which actions they need to take based on that data. One way of putting it is we offer you a team of experts at your fingertips and a network of groundwater and water sensors at your feet. And how we work is that we start from the strategic challenge. So every aquifer, every area, every catchment area will have its own challenges, its specific hydrogeology, and we'll start from the strategic challenge and then build design a monitoring network that can help you address those challenges. And if you say, yes, this makes sense, let's go for it, we'll take care of the full project from end to end, including buying the right sensors, installing the sensors, calibrating them, and taking care of the full process until you have your data available to you on your dashboard. We don't stop there. We'll help you interpret the data and take actions and define next steps with that data as well. Really important consideration is that if you want to understand a water system, I think it's probably intuitive to most of you listening today, is it's not enough just to have, let's say groundwater sensors on their own. Those groundwater data, for example, are linked to precipitation, are linked to nearby surface water. So the entire water system is working as a whole. But more importantly, it's the actions of that our clients are taking, for example, drinking water companies, when they're pumping, infiltrating, managing water levels. It's the insight between how those actions implement the water system you're trying to manage that really give you actionable insights. And what we do at iFLUX is we bring all of those things together from a whole list of kinds of sensors that you see here. We bring in the external data, the client data, and we put it all together in one place so that we can really get our insights. Now, one of our big differentiators here is that we have our specific sensor as well, which is our flux sensor. We have a vertical flux and a horizontal flux sensor. The vertical flux sensor can be installed where groundwater and surface water meet, so at an infiltration pond or a riverbed. We can understand if you're draining or infiltrating and how much and how quickly you're doing that. And with the horizontal flux sensor, we can measure the speed and direction of groundwater movement in real time. And we combine our sensors with the other ones and bring them all together on a nice, clean dashboard, like you see on the right here, so that our clients can really manage their operations. This is what it looks like when we're installing a flux sensor. I won't go into too much detail because at the end of the day, the client doesn't need to worry about that. That's our job, and the client will only pay for the data cleaned and available on the dashboard. But I show this to say one important thing. Quality data starts in the field, so how you install them is key. But there's a lot of magic happening between the installation in the field and really getting your data on the dashboard. And that's where I'm going to go a little bit deeper in the session today. So our sensors are out there. They're sending via different signals, LTI, NB-IoT, LoRaWAN. We're very flexible in what we can integrate. We have a whole device management platform, so we know where everything is, which sensors, which loggers. We bring in the public data, like weather data, the client data, like pumps via different formats, for example, CVS or whatever the format is we get. It all comes together in a data lake where it's stored and secured. And at the end of the day, we want to get that in a meaningful way to our clients in the form of alarms, dashboards, visualization, or extractable data via API. But it's between those two steps that the magic happens, and that's where Timeseer.AI comes in. So in order to make sure our clients are getting real quality data that they can trust and they can take actions on, we need to do a number of things, and we need to ensure that we're working towards an SLA, and this is where we use Timeseer for. So here's a short example that I'll let you see of one of our technicians. So we start from the same dashboard that Rene was showing. We look at it, we say, here on on this network we have a potential quality issue. We're going to zoom in. We're going to say, okay, what's going on? We see there's a sensor with some, a red indicator here. Let's open up that sensor and see what's going on. So each sensor has a number of parameters that it's measuring. Not all of them are relevant for the client. The client wants to see the end data about their system, but we need to make sure we can monitor several things about sensor health so that we can be proactive. We see, there's some auxiliary issue here. Let's isolate those points and let's have a look at what's really going on. So we'll visualize them on a graph and say, that's a bit strange. There's a small time frame where we see something that should be 32-bit is showing a different measurement. That typically happens when we're swapping a logger or a sensor. So we know that this is not meaningful data. We're going to select it and clean it so that we have a nice clear dashboard so that we're sure that the data is qualitative. We're going to decide what we want to do with that data. We want to suppress it, remove it, etc. We make sure we log what we've done, because it's always important to keep the metadata for data integrity purposes, so we know what the full traceability is of your data flow. Say, okay, clean it, suppress it, apply. And within a number of clicks, you've cleaned your data set so that it looks like it should. And you've got a good result. We go back to our dashboard and everything is green. And we're set. We're good to go. So you see, it takes about a minute and a half to identify what the issue is, and move to cleaning. Okay. Now that's one specific example. But once you've set the parameters for your different sensors, you can even apply this retroactively on historical data, which we did on one of our networks that had been there for a while. We implemented Timeseer and said, let's do a retroactive cleaning. You can only do this for parameters you're very sure about. Every blue square here is a time frame that we actually did an automatic cleaning. Now, if we would have to do this manually, it would be a huge amount of work, and here it was done in a number of minutes. So that really saved us a lot of time. So let's zoom. That's what we're doing on the data magic side of things. If we zoom back out and say, okay, why are we doing this? What's really the strategic value of digitizing a groundwater system or a water system? I want to share two cases with you, and then I'll be done for today. One of these cases is Pitpa, Belgium drinking water company in Westerlo. So they have an extraction where they're doing a groundwater extraction, and it's near the Grote Nete, which is a river that has water that's not the ideal quality to use for drinking water production. So what they've done is they've installed a barrier protection wells. So you can see here with the overlay, in green are the barrier protection wells, in yellow are the extraction wells. And what they need to do is they need to manage two things. They need to make sure they have good quality water for the drinking water extraction. And they need to protect those extraction from the Nete, from the water in the Nete. At the same time, they don't want to be negatively impacting the nature reserve, which is on the other side of the river, which is on the south side here in this picture. They don't want to negatively dry out that nature reserve. So what we're measuring with our sensors, 11 horizontal flux and 11 level sensors, we're measuring actually if there's any bypass flows between their barrier protection towards their extraction, so that we can quantify quality risks. We're assessing the impact on the nature reserve with the sensors we've installed on the other side of the river there. And we're modeling with them the right sizing of the extraction and barrier protection wells so that they can continue to have their license. And this is really license to operate questions. It's key for them, to extend and maintain their license to continue their extraction there. With Vitens, so the colleagues of Rene, we're working closely together in the beautiful site in Epe, in the middle of a nature area. Here it's a bit different setup. They're actually taking river water from a cleaner river, and they're using it for a managed aquifer recharge system. So they're infiltrating river water into infiltration ponds. And what they need to do is ensure retention time. So the time between that the water is getting infiltrated in the ground and extracted for production needs to be at least 90 days to ensure bacteriological and virological cleaning of the ground. And those retention times need to be respected. So that's goal number one. And goal number two is there needs to be a balance to make sure we're not drying out this land where we're not extracting much more, maximum 25% more than what we're infiltrating. And so we've set up monitoring system that answers those two strategic questions, a number of sensors for retention and a number of sensors for water balance monitoring. And this gives us insights into how flow directions are going either towards our extraction or away from our extraction from the infiltration point. So it helps us understand water balance. We're also measuring flux speed, so groundwater speed of groundwater movements for different pump combinations, and that allows us to understand retention times and identify potential risky constellations of pump use. And we also identified some unexpected behavior of the infiltration pond, and now we're looking forward to seeing the effects of a cleaning initiative to clean the bottom of the pond to see how that affects infiltration speeds and see if that gives the results that would be desired here. So those are just two practical applications in the drinking water context. Here's just one small example, and I'll stop with this. Of when you bring it all together, really practical. On the top, you have horizontal groundwater flux in speed. On the right here, you have the groundwater flux direction. In the middle, you see the water levels, and on the bottom, you see pumping data. And so when you bring the three data points together, that you start to get a sense of how they interplay. So what you see is in the green highlighted areas, some pumps that were momentarily switched off. You see a small flux, a small change in water levels, where you see quite a direct change in flux speeds. And you see a nice, when you switch off the pumps, you see the groundwater levels slowly start to rise, and you see an immediate drop in flux speeds. And this is just a nice correlation between the data. What I'm saying here again is it's really important to be holistic and bring the different data points together so you can understand the meaning behind it. I'll leave you with that today. I thank you for your time and attention. And if you have any tricky groundwater or water system questions, I'd be really thrilled if you reach out to me. Thank you.
Thank you, Christian.
I'll stop sharing.
Thanks. I will share my screen again. All right, you should see my screen again now. So yeah, thanks again, Christian, for sharing those very concrete learnings, I believe, and use cases. Let me quickly do a recap of the key learnings actually that we touched upon during the webinar, and then we can move into the Q&A session. I see there are questions already in the Q&A box. If there are still any further questions for Christian on the story he just gave, just feel free to post them over there. Key learnings, yeah, I believe everybody touched upon sensor data quality. The future of it is clean, trusted, and actionable. That it is actually ready to drive reductions in non-revenue water, record billing, regulatory compliance, groundwater level management, like Christian was mentioning. Another thing is, of course, we from a Timeseer point of view, we bring technology, but there is a lot of important things going on the people and processes side of things as well. Both Rene and Christian actually touched upon it, like how are you embedding then the technology in your daily workflows, which is of course crucial to get to the real benefits of this. And then something Rene touched upon as well, start small, scale fast. That's also the typical way that it really works, making sure that you get quick wins, minimizing risk, and then prove the value actually early of having that fit-for-purpose data for all the digital water applications you are rolling out, and then evolve and scale over time with those as well. So having said that, that brings us to the end. I will just run through a couple of the questions that you guys have posted. In the meantime, I will also start a poll. It should be under the interactions button. Feel free to give an answer to that poll. It's more related to have you encountered similar data quality challenges as we have shown during the webinar? So feel free to share your answer over there. And then I'm going to move into the questions. We have the first question of Peter, that's to Rene specifically. how do you clean your data from those jump outliers, Rene? So you have shown that specific example around the Qmax. How do you then clean that data is the question.
For now, by hand, and it depends on the conclusions of the investigation. It could be a leakage. It could be a fault in the backend in it HES system of the AMR meters, because not all the data is correct. Dus it depends on the solution, or it depends on the event frame. What is triggered.
Mm-hmm. Yeah, it probably also links to what Christian was mentioning. You also showed like the manual correction is possible, but then also the automated correction. Yes. And in there, it's finding the right balance between which things can you automatically clean, because you only want to clean the ones where you're actually 100% sure it's a real data quality issue that actually can be cleaned. Maybe you can give your 2 cents.
I think for now, Adriaan, it is difficult on the outliers in the Qmax to repair automatically. You must investigate each outlier. It's not possible to do that repairing. You must do by hand for now.
Yeah, the advantage in that use case is especially you have a large amount of data, so it pinpoints you towards the only things that you have to look at, so you don't have to screen everything manually, and then you investigate those indeed that are flagged. Yes.
Yeah. What Timeseer allows is to identify some things that are clearly not correct. Like if you have a temperature measurement and it says, it's 1,000 degrees, we're not on the sun, so that's not possible. So you can directly clear that out. Or if it's already saying, the water levels are 5 meters above the actual place where you're measuring, then you've been doing something manual and it's a crazy data point and you can clean it. But for most of them, you need to contextualize them. So you need to correlate them to other things you're measuring, or even do a real investigation in the field, like Rene mentioned, like, hey, is there something going on? So, but what it gives you the trigger to initiate that proactively, rather than to be surprised by the data at some later point in time.
Yeah, makes sense. All right. The second question is from Leon. How did Vitens deploy Timeseer as an internal or external application? I can answer that one. It's internal, so it's deployed on Vitens premises. And then Rene, I will let you answer the second part of the question. If there were any issues you ran into when integrating it into your existing data architecture that was already in place at Vitens.
No, we are now running on a test environment. We are going to a production environment. I think there we have some issues to clear, but in our test environment we had no issues to connect Timeseer at the Pi historian. It goes very quickly without issues.
Mm-hmm. Yeah, giving a bit of context, indeed, like Rene mentioned in the introduction, so at Vitens we are connecting directly to the OSIsoft Pi system, where actually all the data is stored as well. All right, then the third one I see in here is Adriaan told that data is validated and corrected before front-end systems use it. Where is the corrected data stored? Yeah, that is the consulting answer. It depends. It depends on your data architecture. So yeah, from a Timeseer point of view, yeah, we can write back, for example, to the original data historians where the data is being stored, which will also be the architecture at Vitens, for example. And we have other customers that have their entire setup in more a cloud system setup, where we actually kind of use the Databricks principle of bronze, silver, and gold versions of the data, where that data can then be pushed to. So that we support multiple options over there as well. Then a relevant question from Damiano as well. Yeah, Rene, you mentioned it already. So your line of thoughts, how can we distinguish actually between error and then events affecting our data quality? Is it possible to embed context in the anomaly detection process? So, I think the first one links to what Christian and Rene were mentioning. You typically need to contextualize it. I don't know if you guys still want to add something to that, Christian, Rene. on how you guys are then using that contextualized data to potentially improve the anomaly detection afterwards.
So I think Rene said it at some point. It's like riding a bicycle. You have to get on and start learning how to ride. Hopefully you don't fall and crash, but if you do, you continue. But what I want to say is, there's a first level of cleaning data and seeing things with a human eye and making sure that you're not making wrong corrections, because that's probably the exact opposite of what we want to try to achieve. But Timeseer has the capability to bring in multi-parameter analysis as well. And so if you suddenly see, like, for example, if we see a strange dip in flux, that's not usual, but we can train Timeseer to say, well, if you see these pumps go on or off and you see this interaction, that's normal. So those are the kind of things that you can start to do with this tool. But it's a continuous process. You need to teach it how to think.
Yeah, and I believe, well, the point of view of how Timeseer then works, we actually built what we call an historical background on what's normal based on historical data, like I've shown in the video as well. So that already tunes the algorithms to what you actually see in that data without any special configuration effort that you need to do. And then indeed, like Christian and Rene already mentioned, the more context you provide to it, of course, the more information you have to actually further fine-tune or train your algorithm to even make it more accurate towards the future as well. All right, then we have one question still from Axel. How much effort is the configuration connecting the metadata of the measurement site with the measurement data of a new sensor so that the data quality check can be performed? I think that's maybe something, it's actually a question to both of you. If you connect a new sensor, for example, how easy is it to actually connect it, both the metadata and the sensor towards the system?
We have the PI system, and when we have a new sensor, we create a new tag. And when a new tag is created, you add it at the series set in Timeseer, and you push the button, and you can control the data from there. So it's very easy. Or is that not the question?
Yeah, I believe that's the question. Well, at least that's my interpretation of the question.
It depends on the source.
Mm-hmm.
Within Vitens, for now, we only connect data in Pi. We have another source, the groundwater meeting sensors. We have 5,000 of it. We have also connected, and we are investigating how to work with that sort of data. Is another sort of data. We must also contextualize it, and then we can go further. But normally, with the connection with Pi, it's very easy and fast.
So for us, so as we continue to scale and to implement new monitoring networks, like I mentioned, there's a number of sensors we already work with, but there might be specific circumstances which will cause us to take new sensors into the mix. And for us, it's important that it's easy to add them and to configure them. And that's what we find at Timeseer. For us, it's really important that our base platform is flexible and integratable. And so Timeseer allows us to just bring those new sensors in, to configure them relatively quickly, and then to start working with them. And then the question between the metadata and the measurement that the clients actually see on their dashboard, which is also an important difference. The client doesn't need, you saw a list of 30 different parameters for a sensor. The client is not necessarily interested in all of those, but just wants the end data point. That's something that we manage internally in our systems, and Timeseer is helping make sure that we have the interface between the two. I hope I answered the question.
At least for me, you did, Christian. So if somebody doesn't agree, they can still post it in the Q&A. I still have a final question, I believe, if I look to the Q&A box, and it's more related to the rollout at Vitens, Rene. That's more related to how many colleagues will be working with Timeseer in the end, and how is it organized within Vitens. I think several teams within the organization will be working with it. And how is it organized? Yeah, it's still a work in progress. I will say it links a bit to the start small, scale fast approach in there as well. I don't know if you want to add something specifically to it, Rene.
For now, we in a pilot phase. We would like to go from a test environment to a production environment, and we started with 2 or 3 persons, and I think for now that 15 or 20 persons are involved to get more out of timeshare. We have started with a department ANSC to check the data we are using for our management reporting, important management reporting. And there also you must start small, and then over the time you must learn the people who are involved, what is timeshare and how to work with this. But it takes time. It's not you buy it, you push the button and everything is okay. Then it starts. But you must starting. Yeah? Learn to cycle with your bicycles. The first time with your side wheels, in a short period, and when you think the side wheels you can remove it, then you go for yourself. Because the most important lesson is to get started.
Yeah, exactly. All right. I believe that
one small anecdote to add to the question of how many people are working with it. So with us, it's the IT people and the project managers. The project managers are responsible for having clean data on the system. But actually, we've hung up the central monitoring dashboard next to our coffee machine. So everyone in our organization can see data quality, and we're making data quality a priority. So this is actually one of the major mindset shifts that Timeseer has allowed us to do, because in our business, data quality is just key. So I guess everyone is the correct answer for us.
Yeah, it's especially linked to making the unknowns known and more in your face, that you can also take proactive action indeed on those. So I believe we answered all the questions that are in the Q&A. So the only thing that is left is thank you, Rene and Christian, both for joining the session. I believe it was very valuable to have you in here. I see that also 100% of the people have encountered similar data quality issues and challenges. So it seems to be a recurring topic across the people that joined the webinar. So that's good to see. One thing, we will share the presentation and the webinar recording with all of you after the session, so you can still rewatch it, share it with colleagues or other people. And then we hope to see you again in one of our next webinars as well. So thanks again for joining, and enjoy the rest of your day. Bye-bye.
Thank you all.